All right. Good morning, everyone. I welcome you back into today's class where we're going to be focusing on a access list. Okay, so when we're talking about ACL, so when we're talking about ACL stands for an access control list. So when we're talking about access control list, what does that one mean?
Excuse me, Mr.
Okay,
Hello.
access control
Hello,
list
sir.
is a list of
Hello.
rules that specify which user
Good
or
morning.
system are granted or deny access to a particular object or system resources. Okay, so anytime a network guy wants to deny access to some resources and he wants to grant access to some resources, we can make use of what we call an access list. So this access list just acts as some rules that we put on the network to specify which user or a system can have access to a specific resources and which user or system are denied access to a specific resources. So here now says access list statements are basically packet filter that packets are compared against, categorized by, and acted upon accordingly. Okay, so access list here is just like a packet filter who going to stand by in any time a packet is going out and coming in. Is going to be checking all those packets and is going to see any packet that fall against the rules that you configured on it. So any packet that fall against the rules that you configured on it, access list is going to take action immediately. So here now says creating access list is really a lot like programming a series of if-then statements. If a given condition is met, then a given action is taken. If the specific condition is not met, then nothing happens, and the next statement is evaluated. Okay, so when you're talking about these access control lists, it's just like a programming because we put some list of rules down that if something like this happen, take action immediately. For example, I can have a two network on my company. Maybe I'm using 10.0 and I'm using 20.0 network. I can configure access list and says that anytime 10.0 is going outside, help me to deny it. So access list is now going to stay in action and is going to be checking any packet that is going out and coming in. Anytime you see any packet that is coming out from 10.0, access list is going to deny it immediately based on the rules that you have configured. But if you see another traffic that is coming from 20.0, is not going to take any action because your rule says that it should deny 10.0. So anyone that is not 10.0, no action is going to be taken. So that's how access list works. So the next thing we'll be talking about now is the rules of a access list. Okay, so when we're talking about this access list, we have a lot of rules that abide this particular access list. The first one says it always compares to each line of the access list in sequential order. In other words, it will always start with the first line of the access list, then goes to the line 2, then goes to the line 3, and so on until a match is found. Then the packet is acted upon and no further comparison take place. So when we're talking about this access list, we have a lot of rules that access list use to perform his works. So the first thing says that anytime we create access list, I can create access list and and I have a lot of rules. I can say access list 1 deny 10.0, access list 2 permit 20.0, access list 3 deny 30.0. So we're going to be having a lot of lists of rules. So anytime access list now wants to take action, is going to be going through that particular list from number one. So access list is going to be checking the list from number one. If you check the number one and that number one is not what it say you should do at that moment, it will go to the number two. If that number two doesn't match what he wants to do at that moment, it will go to number three. Anywhere you see the one that match the traffic at that moment is going to take action immediately. And once he take action in it, immediately he's not going to be going to the next list again because he has found the match. So that's how access leaks work. And the second one here says, once the ACL are created, they can be applied to either inbound or outbound traffic on any interface. Okay, so anytime we are creating ACL, if you just created your ACL and you did not attach it to either inbound or outbound, your ACL is not going to be working. Okay, so anytime you are creating the ACL, you need to attach these particular rules to either inbound or outbound ports so that those guys will be the one to be taking action on the traffic immediately. Okay, and the third one says there is an implicit deny all at the end of each access list. This means that if a packet does not match the condition on any of the line in access list, the packet will be discarded. Okay, so inside access list, there's what we call an implicit denial. So let me make this example like this. Let's assume that I have like three networks. I have 10.0, I have 20.0, and I have 30.0. So anytime I create my access list and I say that an access list permit 10.0, access list permit 20.0, and I say end, by default, access list is going to deny 30.0 because inside access list, there's what we call an implicit deny all. If we have any traffic that doesn't match any list, the traffic is going to be denied by default. For like the example I made, I have like three network 10.0, 20.0, and 30.0. Anytime I tell my access list that permit 10.0, permit 20.0, by default 30.0 going to be denied. That is what an implicit deny all is. At the end of the traffic, there's what they call an implicit deny all. So inside this access list here, we have a lot of list of many security threats we can mitigate with an access list. So we can use this access list to mitigate IP address spoofing. So we can use it to mitigate IP address spoofing, which is we can use it for the inbound, which is the one it's inside, and we can use it for IP address spoofing for the outbound, which is the one that is outside. Okay, so we can use a DOS TCP sync attack. We can mitigate ACL with a DOS TCP sync attack. We can using it to be blocking an external attack, and we can use it to block DOS TCP sync attack using a TCP intercept. So we can use these ACLs to block this type of attack on our network. When you don't want anybody to be spoofing on your network, we can use ACL. When you don't want any type of a DOS attack on your network, we can use ACL. The same thing with a filtering ICMP message. If you don't want anybody to be sending a fake ICMP message into your network, we can make use of an ACLs to deny all those traffic and all those attacks. Okay, so here, when we're talking about this particular ACL, we have a lot of a list. We have a lot of list of rules that we can live by when we are configuring ACL. So here says that here is a list of rules to live by when configuring ACL on your edge router to filter internet traffic to your production and network to mitigate security problem. So imagine we have a edge router on our network. If you are using ACL, we have some rules that we can configure on the ACL that can help us to mitigate any security problem. So the first one, we need to deny any addresses from your internal network. So we need to deny any addresses from your internal networks so that you don't want anybody to be using fake IP address to be launching attack. We need to use ACLs to deny any address from our internal network, and we need to deny any local host address of 127.0.0.0/8. So we need to deny any local host address, and we need to deny any reserved private address. Reserved private address class A, class B, class C. all those IP address that we use on our private, all those private IP address, we need to deny all those IP so that we won't have what we call a security problem on our network. And the next one says we need to deny any addresses in the IP multipass address range of 224.0.0/4. So all these things here, those are the first thing we need to do on our router anytime we are making use of a ACL, which is a access control list. So we need to deny all this type of address so that we're not going to be having a security issues on our network. So when we're talking about this and ACL, as you all know, ACL is just like a security techniques that we implement on our network that we use to allow or deny access to a resources. So when we're not talking about this ACL, we have different types of an ACL. So here we have two main type of ACL. The first one here is a standard ACL, and the second one is a extended ACL. So when we're talking about standard ACL, ESA standard IP access list filter network traffic by examining the source IP address in a packet. So when we're talking about this standard access list filter network traffic by examining only the source IP address. So standard access list based on only the source IP address to filter any traffic. So anytime a standard access list wants to act upon, is going to check the source's IP. It work upon the source's IP address only to filter the network and to deny or permit access based on the rules. So here now says that you create a standard IP access list by using the access list number of 1 to 99 or 1300 to 199. So anytime you are creating a standard access list, there's some numbers that you need to attach to it. So anytime you see a standard access list, the number you can use is from this range 1 to 99, or you use 1300 to 1999. Those are the number. So anytime you see something like this, you see IP access list 20, you have already know that they are using a standard access list. Or you see access dash list 50, you know that they are using a standard access list. Here now says that access list type are generally differentiated using a number. This type of access list is configured on a destination router. So anytime that you want to be configuring a standard access list is only configured on a destination router. And I explained to you that this standard access list has some numbers that is from 1 to 99 and 1300 to 1999. That's the number that is attached to a standard access list. So anytime you see a ACL rules, for you to differentiate which type of access list is this is based on the number. So anytime you see a ACL that is attached with a number of 50, you know that that type of ACL is a standard access list. And this standard access list is only configured on the destination router. So the second type of access list is when we're talking about extended access list. So the second type of access list is a extended access list. When we're talking about extended access list block or allow network traffic based on source and destination IP address. As you can remember, when we're talking about standard only blocks or allow network based on what? Based on source. Standard only use source IP. But when we're talking about this extended use both source IP and destination IP address. And extended can still go far to be using the port number. Extended can use port number, it can use protocol, it can use a lot of things different from what we're talking about standard access lists that only make use of a source IP address. Okay, so here says that extended IP access list blocks or allow network traffic based on a source and destination IP addresses, port numbers, protocol as opposed to just source and addresses. So extended access list number are in ranges from hundreds to 199 and from 2000 to 2699. So that is the number attached to extended access list. As we all know as well, the standard access list has its own ranges of number that is attached to it. The same thing to this extended access list. So anytime you see ACL that is attached with a number of 100, you have already know that that type of ACL is a extended access list. So for you to see the number, is going to let you know the type of ACL is that. Okay, so let's move into the next. So here now says that this type of ACL is configured on a source router. So I want you to put this in mind, as you already know that that an standard access list is configured on a destination router. Extended access list is configured on a source router. So anytime that you want to configure extended access list, you're going to be configure the extended access list on the source router. Anytime you configure standard access list, you're going to be configure the standard access list on the destination router. So here is a question. Here says, what if you needed sales to gain access to a certain server on the finance VLAN, but not to other network services for security reasons? Which access list should you use to accomplish this task? So as you see this question here now, we only want sales to gain access to the server that they are using on a finance VLAN. It is only sales that they want them to gain access to finance VLAN server, not other network services. So if you want to do this type of ACL, which type of ACL are you going to be using? So here now says that, well, with a standard IP access list, you can't allow users to get to one network services and not another. Okay, in a standard access list, there's no way you can differentiate what you want them to get to from another one. You won't be able to accomplish that goal with a standard access list. So here now says the access list to use in this case is an extended access list. So please always use extended when you need to make decision based on both source and destination addresses. So if you see this particular question, here now we need sales to gain access to a certain server on a VLAN, on a finance VLAN. Sales to finance VLAN. So anytime you want to make a decision based on the source and destination addresses, anytime you are creating that ACL, make sure that you are using an extended access list, because with a standard access list, you won't be able to accomplish that particular goals. So here now says a standard access list won't allow you to do that, since it makes decision based on the source address only. As you all know, standard only make decision based on the source address only. But when we're talking about extended makes decision based on the source. It makes decision with the destination, and it still go ahead and make decision with the port number, protocol, and so on. Okay, so here now, we're going to bring up our packet tracer, and we have three questions that we're going to be solving with ACL, and you're going to know how ACL work. So we're going to bring out our packet tracer. So we bring out our packet tracer. So once we bring out our packet tracer, we're going to build a network. Okay, so the question here, we have three questions here. So we have built up our own lab as well. So here is our own topology. So here is the question that they give to us. They say that use a standard access list to deny branch office devices telnet access to branch office router. So here now, they say we should deny branch office telnet to branch office router. Okay, so here is the system on branch office, and here is the router on branch office. They say we should deny these people from telnetting to the router on this branch office. So before we can deny telnet, we need to enable the telnet, and we need to confirm maybe the telnet is working. So once the telnet is working, we will go ahead and deny the telnet. So if you come down, here is the command to enable the telnet on the branch office router. Here is the command. We're going to use enable conft, and here going to use enable secret Cisco 123. So as you all know, if you want to enable telnet, you need to enable a secret password. After that, we need to go into line VTY 0 to 4, which is the line that is working for telnet. Line VTY is the one that is responsible for telnet. So after we put 0 to 4, 0 to 4 means that we only want 5 people to be able to telnet at the same time. So the password we are putting anytime they want to be logging in through this telnet, the password we are using is a Cisco at 1234. That's the password they will be using, and the purpose of the password is for login. After that, we type end and WR. So let's go ahead and enable the telnet on the router. So here is the branch office router. We're going to type enable and conft. So once you type enable conft, the first thing we're going to be doing here is to enable the secret password. So you can see the secret password they are using here is a Cisco at 1234. So we'll go back to the router. We'll go back to the router, and we're going to type enable secret Cisco at 1234. So we hit enter key. Okay, so once we hit enter key, here now we are using 1, 2, 3, 4, 5. So line VTY is 0 to 4. So we need to enter the line that is responsible for that particular telnet. So I can actually change this to 1, 2, 3, 4, 5. So next thing is to enter line VTY is 0 to 4. It's not a must that you must use is 0 to 4. If you like, you can use line VTY is 0. If you put only line VTY is 0, it means that you only want only one person to be able to telnet to the router. You put in is 0 to 4, you want 5 person. So what's the function of telnet? This telnet here is the one that give us a remote connections to the router. So anytime anyone here wants to be inside this router, they don't need to be going to wherever the router is. They can remotely connect to this router. And when they are remotely connecting is what they are using to remotely connect to the router is what we call telnet. Okay, so we are enabling the telnet. The first thing we enable the secret, we enter the line. The next thing is to say password Cisco at 12345. So we'll go back and we're going to say the password we want to be using. So we're going to say the password that we want to be using is a Cisco at 12345 with enter key. So after that, the function of the password is to log in with enter key. So after we log in, we're going to type end and WR. So we are able to enable that particular telnet. So let's check maybe the telnet is working or not. So anytime we want to check, if I come back to this topology, we're going to use any of this system. If I come to this first system, you close this icon, you're going to see the command prompt. If I open the command prompt, you're just going to type telnet, and you're going to put the IP address of the router, which is 192.168.5.1, and hit enter key. Immediately, it's asking you for password. We're going to be using Cisco at 12345. Hit enter key. You will see that we are inside the router. So we are able to telnet inside this first router. So if I type enable here, it's going to ask me for the second password, which is a Cisco at 12345. So this guy is going to ask you password 2 times. So you can see that we are inside this particular router. If I type conft, I will be inside the router. So what I'm going to do here, if I change the name of this router by using this command host name, and I name it branch office router, branch office, and hit enter key. So as you can see, I'm able to name this router. If I go inside this router, you see that before we are using router, but if I hit enter key, you will now be able to see branch office. It's because that we are able to change it from this system because we are able to connect to that particular router. So the telnetting is working. If I use the second system as well, it's going to be working. Just type telnet, the IP address of the router 5.1, ask you for password. The password is a Cisco at 12345. Hit enter key. You will be inside that particular router. So what's the task they give us now? Inside this task, the first question said that we should use a standard access list to deny these branch office devices telnet access to branch office router. So what they now say we should do here now is that they said that they don't want anyone here to be able to telnet to this router. That is the task that they give us. They say that we should use access lists to deny these people from telnetting to this router. So how do we go about configuring the access list to deny them? So here is the command we're going to be using. The first one here is a enable conft. Once we use enable conft, we're going to be in our global configuration mode. So the next thing we're going to be using access-list 50. So for you to be seeing access-list 50 is showing you that we are using a standard access list. We are using a standard access list because here is the source and here is where they are heading to. So as you all know, anytime you are configuring a standard access list, it's configured on a destination router. So anytime people here wants to telnet to this router, here is the source and here is the destination. So that's the reason why we are configuring a standard access list and it's going to be configured on this router. So what we're going to be do, we go here now, we are in a global configuration mode. So we don't need to be typing enable and conft again. So I'm just going to be using access-list 50 deny 192.168.5.0, which is this people network. These people network, those are the people that we want to deny their telnet. So we're going to deny them. So let's head into the router. I'm going to say access-list 50 deny. Who are we going to deny? We're going to deny 192.168.5.0 with their wildcard mask of 0.0.0.255 and we hit enter key. So here there is a little issue. So I need to go to global conft. Okay, I'm in global configuration mode. After that, I'm going to type access-list 50 deny 192.168.5.0 wildcard mask of 0.0.0.255 and we hit enter key. Okay, so let me explain this function of this particular command here. So here we are using access list 50 to deny. So we are attaching 50 as I explained to you. Anytime you are creating your ACL, you're going to attach numbers to it. So for you to attach 50 to this ACL, is telling us that you are using a standard access list because it falls inside the range of 1 to 99. Okay, so we are using access list 50 to deny these people 5.0, which is the network. We are denying them. So the reason why we are using wildcard mask is that this 192 here must be one. This 40 here, it says that 192 must be 192. Second zero says that 168 must be 168, it must be constant. And the third zero says that 5 must be 5. But this 255 now says that this zero here can change to anything. So we are telling access list 50 that anytime 192.168 5.0 network, it can be 5.1, it can be 5.2, 5.3, 5.4, 2, 5.254. Anytime they are going to telnet, help us to deny them. That's function of this first command. So after that, we need to say access list 50 permit any. As you already know, when I'm explaining the theory aspect of this ACL, I tell you that there's what we call an implicit deny all. If I just leave this thing that this, access list going to deny the remaining people. So we need to tell access list that it should help us to permit any IP address, that it is only this guy that we want to deny you. Help us permit any IP. So that's the reason why we say access list 50 permit any, so that it's not going to deny everybody. So we need to say access list access list 50 permit any. So it's telling you it should help us to permit any IP address. So after that, we need to enter that particular line VTY that is working for telnet. So we need to enter line VTY that is responsible for telnet. So I'm going to type line VTY 0 to 4, which is what we use to enable our telnet. So after that, we're going to say access dash class 50 in, which means that we are putting this our access list 50 inside this line VTY 0 to 4. So we are saying that anytime anybody wants to telnet to this router, this line VTY 0 inside line VTY 0 to 4, access list 50 will be the one to be inspecting it. And once you inspect it, you see that the network is coming from 5.0, immediately is going to deny them based on the rules that you configured. So here we're going to say access dash class. So we're going to say access dash class 50 in inbound, and we hit enter key. After that, we say N and W out. So that's all. So let's check our ACL, maybe is working or not. So if I come back to this topology and I come to this first system, if I open the command prompt and I use telnet, so let's see maybe it's working or not. If you use telnet IP address of the router 5.1 and we hit enter key, you're going to see the message that say connections refused by remote host, which means that ACL is be the one that is denying it, because this guy, it is inside 5.0. If I come back to this guy, as you can see that we are inside before. So we are inside before. If I close and I open my command prompt, so if I exit, so we stop it. So if it tries to connect again, it's going to be reversing. ACL is going to be denying it. It's not going to allow it to happen. But let's try to use 4.0. Let's see, maybe it's going to be working or not. So if I open my command prompt and I type telnet 192.168.5.1, I hit enter key, you're going to see that this one is working. The reason why it's working is that we only tell our ACL to deny 5.0. So it's not everybody that we say it should deny. If it comes to our rules, we see that it should deny 5.0, but it should permit any IP. So that's the reason why it's working. So that's how you can use an ACL to deny access based on anything that you want. So that's how you can use ACLs to deny